But let's see, we have a weight of a certain type of brick has an expectation of 1.12 and a standard deviation of 0.03. Because part A says, what are the expected value and variance of the average weight of 25 bricks randomly selected? So this one's just a little bit harder. But part A is still possible of what we can do. Okay, so on the exam, I probably wouldn't say the average of 25 bricks because that just seems like it'll confuse you a little bit more. But I would ask you, find the expected value and standard deviation for the total or the sum of the 25 bricks. And at that point, that's pretty easy. But for the average, how do you find the average? Let's call this x. So how would you actually get x? To find the average, I'd have to do x1 plus x2 plus x3 plus x4 plus dot 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 plus x25 all over 25, right? And then how would you find that expected value? So it would have to be the expected value of, again, x1 plus x2 plus up to x25 over 25. Okay. Now this divided by 25, can I just pull that straight out? Let's just pull that out as 1 over 25 times, and then we'll do the expected value of each one. So expected value of x1 plus expected value of x2 plus the expected value of x25. This is going to be 1 over 25 times, now each of these expected values, what were they supposed to be? 1.12, they're each going to be 1.12, and how many of them am I going to have? I'm going to have 25 of them. And so I just get back to 1.12. Okay. Now this is doing it based on our rules, and as far as the exam, I expect you to just remember what it is based on the rules. But do you remember how we did one example in class where we found rules for our average? Okay. So in the book on page 134, we have rules where the expected value of the average, so this x bar means average, is just equal to mu. Okay, so if xi has expected value of mu and variance of xi equals sigma squared. Okay. So the expected value will just be equal to mu. So in our case, the expected value of x bar is just equal to mu, which in our case was 1.12. And so you didn't actually need to do all of that work for this homework problem. If you remembered, we did that one little thing. And the book also tells us that the variance for your average is just equal to sigma squared over n. Now, could you figure it out without using the formulas and just doing what we know about variances? Could you go through and say the variance of x, let's just change these to x bar since I remembered you guys do know this notation. The variance of x bar would just be the variance of x1 plus x2 plus dot 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 plus x25 all over 25. And you could go through and use your variance rules and you could figure out what this is. Or we could just use our formulas. We'll say it's just sigma squared over n. They didn't tell us sigma in this problem, but they did tell us that the standard deviation is 0.03, which means the variance of each one is 0.03 squared, which is just 0.0009. So in our case, it's going to be 0.0009 over n, and there were 25 of them. So 3.6 times 10 to the negative 5. And the standard deviation of x bar would just be the square root of that. Which is 0.006. So that's what they had in mind for you to do on that problem. What I would have in mind on the exam would be just kind of working out with our rules. There's not actually one like this on the exam.